Alright, chapter 4.3. This is about patterns and nonlinear functions. Yesterday we looked at linear functions. We learned that a function is linear if the rate of change is consistent throughout the relationship. That was where we found the rate of change over a series of values and found out that the answer or the change going on was the same throughout. We also learned that the symbol m represents rate of change, or as I've said a few times, slope, which you'll learn about in chapter 5. And we learned to use the equation y equals mx plus b, which you were supposed to memorize and learn to use to plug in the information to create a rule. Today what we're going to do is work with nonlinear functions. While checking the rate of change of the relation, we know that it's nonlinear if any of the rates of change are not the same. So when you go to check your table and you see that the difference between these is 3 and the difference between these is 3 and the difference between these is 4, that represents nonlinear because one of those numbers is different. So again, if every number is the same, it's linear, but as soon as one number is different, like you don't even have to check. If that was 3 and that was 4, there's no need to check. Once the numbers are different, it's going to be nonlinear because the rates of change are not the same. The particular functions we're going to look at are going to be of the type x squared and x to the third. Really don't get it wrong. After you learn this, it doesn't mean you'll be ready for everything that has an x squared and x to the third, because those things can be complicated. We are looking at the very basic level of x squared and x to the third, but our job has two parts. First off, we got to learn to identify which type it is, and we've got to learn how to create a rule for the new type. So this has a two-part job for you. Neither one of them is really that bad, but the second part is going to require some discipline from you. The essential question is, why is finding the rule for nonlinear functions different than finding the rule for linear functions? Because it's not a straight line. It doesn't fit a set formula with the y equals mx plus b. Instead, we're going to have to organize our work and use our analysis to think through the process. So it's, again, going to take some discipline. It's going to take some practice to get to where you need to be. Linear functions utilize x as the variable, and that's because we found the match on the first check. So a match on the first check is x to the first power, or x, because as you know, or as you should know, anything to the first power is itself. So 9 to the first power is 9, 10 to the first power is 10, and so on. So x to the first power would just be x. And the reason we use x is because the first check means we're x to the first power, which again is just a regular x. Nonlinear functions require a second or third check before we find a match. And what I mean by finding a match is that the rate of change between each part is the same. But the thing is, and this is how you learn to type, if it matches on the second check, then we put x to the second power. So again, if the second check makes all the numbers match or make them the same, we'll talk about what that means in a second. But if the second match works, then it's going to be x to the second. If the third match works, then it's going to be x to the third. In higher level math, you'll learn that if the fourth match works, then it's going to be x to the fourth. If the seventh match works, then it's x to the seventh, and so on. So it's kind of like just breaking down the differences, and once you identify where the match occurs, that's what tells you what power that you'll have on your x. Again, first check or first match is x to the first, and that's how we just use it, x. So real fast, how to determine if you see a question like this and you need to know if it's linear or nonlinear, whether it's a table or a set of ordered pairs. First off, again, 0, 1, 2, 3, 4, so my x's are moving by 1. I don't need to divide. The difference between 5 and 4, 5 minus 4 is 1, so that's plus 1. From 9 to 5, 9 minus 5 is plus 4. 18 to 9 is plus 9. 34 to 18, if you don't know, just do 34 minus 18, which is 16. And notice this does not match. In yesterday's work, those numbers would have all been the same because it was linear, but this doesn't. So what we got to do now is check the check. So we do these numbers. From 4 minus 1 is up 3, 9 to 4 is up 5, 16 to 9 is up 7. The second check did not work. That means it's not x to the first. It's also not x to the second. But when you check the third level, 5 minus 3 is 2. 7 minus 5 is 2, and notice that the first level did not work, second level didn't work, but the third level did. So this is a x to the third type. Now we don't know what the pattern is, but we do know that this pattern here has to be an x to the third because it took 1, 2, 3 checks to get to our matching number. again, if it would have matched here, we would put it in the y equals mx plus b because that would have been m. But don't confuse those two numbers for m. That is not a rate of change. That is not m. That is just a match. Alright, so now that you have seen how to identify the type of nonlinear function, it's time to see how to create the rule. So again, I didn't give you two examples because in all honesty, you're either going to see ones that match on the first, match on the second, match on the third. That's more for your homework and your practice. But you now can see what you're doing, which is if the numbers don't match up in between or in your differences, check those differences and then check another level and then check another level until they all match. Unfortunately, there is no formula to make this a direct process, but it will take patience and practice. I just believe that you can do it if you follow the advice that I'm going to give you, which is here. And make sure you practice this and make sure you study this because you need to know this stuff. And then once you do it enough, you don't need these steps. You can just kind of do it out of habit. But what you want to do first is identify the type of function. That's what we just did. Is it a second power, third power, fourth power, and so on? Second, make a chart for analysis. Again, this is where a lot of you aren't going to want to do it because I see a lot of people bring their computers up with no paper, and so they want me to tell them the answer, but they don't even have the problem on paper. If you're going to get help on these, I need to see your chart, because if you don't make a chart, then you're just kind of doing it in your head, which is going to be tough to do. Once you have your chart, you should be able to look at it and determine what the shift is. That's just a matter of going through some problem solving in your head, and then you just take that shift and write the rule in algebraic form. So looking at the example above, which was this one. Once we have found out the type, which was step one, it says make a chart for analysis. Now here's what you want to do. Depending on what it is, again, this is only for those that have x to the second or x to the third. Your chart is very basic. You want to put your x down, you want to put whatever type it is, which is x to the third, and you want to see what y is. From there you list everything. When x was 0, x is 1, x is 2, x is 3, and x is 4. Those are all of your x's, remember, because that's an x, 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 and an x. So those numbers go into your chart as your x's. Then you use your calculator or your own head if you can. I mean, you can do that. Just make sure you understand x to the third means multiply it by itself 3 times. 0 times 0 times 0 is 0. 1 times 1 times 1 is 1. Pretty much you're just plugging this in here. 2 times 2 times 2 is 8. If you don't know that, just hit 2 to the third to see for yourself that it is 8. 3 times 3 is 9, times another 3 is 27. 4 times 4 is 16, times another 4 is 64. In all honesty, if you work these out enough, you'll memorize those numbers because you'll see them enough times. By the way, 5 times 5 times 5 is 125, and the faster you get at recognizing that, the faster you can fill that part of the chart out. So it's not really, it's just writing. It's not really going to be time consuming because again, you're going to get 0, 1, 8, 27, 64, 125 over and over. Then you want your y values, which are here. 0 for x led to 4 for y. 1 for x led to 5 for y. 2 for x led to 9 for y. Did it? 0, 4, 1, 5, 2, 9. That's the problem. 3 for x led to 18 for y. 4 for x led to 34 for y. I don't think this is going to work the way we want it to. Nope. I think something messed up in that pattern, so I don't think I'm going to be able to show you what I need to show you here unless I messed up somewhere, which I'm pretty sure I did because I've been doing that a lot. I think we will do it more on the examples and look at those because I know for a fact that those do work, so I'm sorry. I just wasted a little bit of your time. But you will see that things do actually work like they need to in this. So don't consider that example. Consider these examples on the back of your sheet and cross that out because something is wrong with that I cannot fix there. So here we go. Go into these 3 examples that I have on the back. 0, 0, 1, 2, 2, 16, 354, 4, 128. Again, the first thing we need to do is check to make sure our x's aren't doing anything crazy, which they're not. 0, 1, 2, 3, 4 means they move by 1. That is up 2. That is up 14. That is up 38. this is up 74, and of course that means it's nonlinear, because once it doesn't match here, that would be the m that I would use in my formula, but of course they're all different, so we can't do that. This is up 12, this is up 24, this I believe is up 36 if I'm right. 74 minus 38, yep, it's 36, which means it's not an x squared. My third check gives me 12 here and 12 there, which means that it is x to the third. So again, what I want to do is make my chart, my x, the type, which is x to the third, and my y, and this is again where your pattern comes in. Your x's are 0 through 4. Your x to the thirds, remember that's 0 3 times, 1 3 times, 2 3 times, 3 3 times, 4 3 times, which is 64, and then your y's are 0, 2, 16, 54, 128, and this is a lot more what I'm looking for. So again, step one, I'll go back to the notes so you can actually use those as we go through the actual example that works. Step one was to identify the type, which we did. We did our difference check to find out that it worked on the third time. Step two was to make a chart, which we did. Now it says determine the shift, and when you're looking at the shift, you're only looking at these two numbers. What am I doing with this number to make that number that I'm also doing with all these numbers to match? So you got to find one thing you are doing with this chart, this list, to make that list. We don't really care about this anymore because that was just to help us get our x to the third part, but this is what I'm looking at. Obviously I'm not adding anything, because if I add or subtract something to 0, that would be a different number, so that's not it, which means take addition off the table, take subtraction off the table. Let's look at multiplication. So you don't think multiplication here, but I can multiply 1 by 2 to get 2. So think multiply by 2. Is 0 times 2 0? Yes it is. Is 1 times 2 2? Yes it is. Is 8 times 2 16? Yep. Is 27 times 2 54? Yep. 64 times 2 28? Yep. So what you're doing here is you're multiplying by 2. And what it says last is, once you have determined what the shift is to write it algebraically. This is where your chapter 1 modeling came in. We know that we're taking x to the third, and we know we want to multiply it by 2. And the way you write x to the third times 2 is the rule y equals 2 x to the third. That is our rule. And just to show you, which is what you're going to be doing also, is you're going to take 2 parentheses 0 to the third just to verify, to see you get the answer of 0. You can hit your up to bring up that copy and paste. Go back and turn that into a 1, and notice you get the answer of 2, which is what we're looking for up here. Steal that information again, turn that 1 into a 2. Notice we get 16, which we need right here. Sorry. Go up, still another one. Turn that into a 3. Notice we get 54. Turn that into a 4. Notice we get a 128, which means that our generator does work. Again, the key thing is you must look at, don't worry about, this is used, the X column is used to get your name column, but once you get that, you really don't need your X column anymore. You are looking at how did this level, or what am I doing with this number to make that number. Thinking addition, thinking subtraction, thinking multiplication, and in worst case scenario, thinking division. You're usually not going to use division. It's going to be one of these three. So just use your, again, your thinking, your analysis, your patience, your experience to kind of get you where you need to be on that. Second example, again, my x's are going 1, 2, 3, 4, 5. So we look at this and we go 2 minus negative 1, because remember it's second minus first. That's what we worked on yesterday. That means that this is going up 3. This is going up 5. This is going up 7. And this is going up 9. Not an x squared. This is going up 2, going up 2, going up 2, which means it has to be an x squared pattern. Alright? The fact that it's an x squared pattern means now I make my chart, but instead of using x to the third, I'm going to use x squared, x and y. Using the numbers for x, 1, 2, 3, 4, and 5. Squared means multiply by itself. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. We then fill out our y's, which is -1, 2, 7, 14, 23. Looking at your options again, you don't care about this anymore. You are now looking at what did I do with these numbers to make the y's. Obviously it's not addition because 1 drops to -1, 4 drops to 2, and so on, so addition's off the table. Look at subtraction. 1 minus what makes -1? Don't even want to think about that. Let's look at another one. 4 minus what makes 2? That would be 4 minus 2. So 4 minus 2, let's think about subtracting 2. Is 9 minus 2 7? Yep. Is 16 minus 2 14? Yep. Is 25 minus 2 23? Yep. And just to make sure, if you're not good with numbers, check out to see what 1 minus 2 is. Notice that it works, which means what we are doing here is subtracting 2. So to make this a algebraic rule, we know that we have x squared. We know we are subtracting 2. To do that algebraically, we would put y equals x squared minus 2. And again, to check that, what we would do is go ahead and put 1 squared minus 2. 1 squared minus 2, which gives me my -1, 2 squared minus 2, which gives me my 2, 3 squared minus 2, which gives me my 7, and so on and so forth. Alright? And then the last one, 1, 3, 2, 1, 3, -1, and so on. Our x's are going 1, 2, 3, 4, 5, which is good. 1 minus 3, which is where some of you messed up. 1 minus 3 is -2. That means that's going down to -1 minus 1 is also -2. -3 minus -1, just to verify so you can see it for yourself, is also -2. And once I start seeing that, I now recognize that this is the same, which means that this is a x equation. Because it's an x equation, it means that I now will use this as my m, because it's only like that on my, this is like the one from yesterday. So whenever it matches on the first, we go back to our m equals -2, because that is our consistent rate of change. It is linear. And so now we do our y equals mx plus b. We choose one point. We take our y, plug it in, take our m, plug it in, take our x, plug it in, and wrap up the rest. 3 equals -2 plus b. Add your 2 to both sides, getting 5 equals b, which means my answer, remember on this, you plug in m and b back into the slope, or to the formula generator, which is -2x plus 5. Again, to verify, -2 times 1 plus 5 is 3, which works. -2 times 2 plus 5 is 1, which works. Typically, if it matches 2 of them, it's going to probably match all of them, but again, that would be your pattern here. So your challenge today is to make sure you know how to do the ones that are linear and the ones that are nonlinear all at once. You'll have a brief quiz tomorrow after I give you some review time and some practice time, but other than that, the final thought is that it's important for you to make sure you know when to use the formula, the y equals mx plus b, versus when to use the table. The formula only works for linear functions, again, only whenever that first check works. Otherwise, you're going to have to use your organization and you're going to have to analyze some things. Again, make sure you practice this. We are moving on Monday, or on our next lesson tomorrow after our quiz. We will not be doing this for 2 days in a row, so make sure you're ready to go. Other than that, good luck.